So this is what I mean when I talk about the central eye of least resistance. Now, we know this pattern. We've seen it everywhere, actually. It's pretty much in everything in our universe. It's a solar system, it's a galaxy, it's a black hole, it's the sun, it's the earth, it's everything, right? It's in the middle of tornadoes and hurricanes and water funnels. It changes only in scale, but the pattern is the same. And it pretty much does the same thing in every medium on every scale. Now we know when we have a hurricane or a tornado on the earth, that's the little earth in the vortex. But anyway, we know that in the middle, there's always this eye of the storm or eye of least resistance. And it's the same thing when you stir your coffee or a bowl of water, right, with some sand in it. But what you end up with is, if you looked at it from the top, would be something like this. There's always an eye in the middle, and then there are these waves that move out from it. And they don't just go in opposite of the direction of spin, they also go forward the direction of spin. And generally, anything that is caught in this turbulence out here is being slapped by these waves. It's being pushed out, which is centrifuge. That's the waves pushing you outward, slinging you outward, and being pushed down and in towards the eye at the same time. And what it's doing is your body will try and become neutrally buoyant, so to speak. And you're going to try and center on that eye because here there's no resistance. This is a place where all forces equal out, push and pull, everything equals zero. And you're allowed to sit there and be comfortable and float, weightlessly, essentially. Now, the same thing happens inside the eye of a tornado or a hurricane. We know that. The same thing happens in space. When a massive object, such as the sun or a planet, spins for whatever reason, which pretty much everything is doing is rotating, even black holes rotate. But anyways, when something spins, it actually warps space, the medium of space. I think we're currently calling it space-time, but it's pretty much just a medium. When you're on this massive scale, it's definitely a medium. It's much more dense to these giant planets than it is to us tiny humans. But this is what you would get if you looked at it from the side, which is essentially what magnetic spectrum looks like also. It's what galaxies look like from a distance. There's always the central eye spinning, and there's other things caught in that spin. Now, this is what our sun is doing to space around it. Our planets are also creating their own little eyes with their own spin, right? And that's helping our planets actually resist the overall waves of the sun. But more on that. Essentially, our planets are caught between centripetal and centrifugal forces, which is these waves right here. You can see them. All right, so one set of waves is actually trying to sling them out, and one set of waves is curving down and pulling them towards the center, right? That's what's happening to everything. That's what's happening to our bodies on the earth. The earth is the same little eye, and we are things that are stuck to the crust of the earth, right? The earth is spinning and disrupting space in the same fashion on a smaller scale. And while it's being pulled towards the sun, the central eye of least resistance, it's also being slung outward centrifugally, right? The same thing is happening to us. We are being pulled towards the center of our planet and being slung out centrifugally. Now, the thing is, I think they might equal out. So what I mean is, if you, essentially, let's pretend we're in a little tornado. Now, in space, the faster the spin, the deeper the well becomes. So let's say there's our eye. Okay, so that's your deep little well in space, right? That's kind of like the top of this spot right here. Now, the faster you spin, the deeper the vortex becomes. The taller and deeper it becomes, and the taller these arches become. The slower you spin, okay, let's just pretend we're right there. Now, the slower you spin, the shallower the well becomes that the eye creates in space, right? And essentially that means that if you spin faster, you're slinging things outward with more centrifuge, but they're also being pulled in with more warp, right? So no matter how fast or slow the eye spins, same thing here. If it spins slower, you have less centrifuge going out, but you also have less force pulling you in. So no matter how fast the eye spins, gravity will seem about the same because they're always counteracting each other. They're always equaling out, right? It's kind of a progression. But the thing is, if this eye stops spinning altogether, then what you end up with is everything just kind of dematerializes and floats off to space. It gets sucked into black holes or other eyes of least resistance in other places. But that's essentially what I mean when I'm talking about an eye of least resistance. That's what you get. And you can see this in all mediums. And remember, to these massive planets, space is much more dense in their scale than it is to us.